አሁን የሚቀርብላችሁ የዲዛይን ኤንድ አናሊሲስ ኦፍ አልጎሪዝም ላይ ፎከስ የሚያደርግ ነገር ግን ኢንትሮዳክሽን ቱ አልጎሪዝም አናሊሲስ ስፔሻሊ አሲምፕቶቲክ ኖቴሽን እና አናሊሲስ ኦፍ አልጎሪዝም ላይ ፎከስ የሚያደርግ የጥያቄና መልስ ተማሪዎችን ለማበረታታት በኮርስም በኤግዚትም ጭምር ተማሪዎች እንዲበረታቱ ታቅዶ የተሰራ ስለሆነ ስለዚህ ይሄንን ዩቲዩብ ቻናል ላይክ ሼር ሰብስክራይብ በማድረግ እንዲያግዙን እንዲደግፉን እንፈልጋለን ለሌሎች እንዲደርስ እንዲሁም ላይክ ሼር ሰብስክራይብ በማድረግ ያግዙን እንላለን አዘዘ ለቻት ቲዩብ ይባላል ቲዩባችን አይለዩን ይመልከቱ እናመሰግናለን Question number 1 Which of the following best defines an algorithm? A sequence of steps to solve a specific problem. B. A mathematical equation. C. Random instructions. D. A programming language. The correct answer is A. A sequence of steps to solve a specific problem. An algorithm is defined as a set of instructions or step-by-step procedure to solve a specific problem or to perform a specific tasks in a finite amount of times. These instructions are unambiguous and can be followed by a computer to achieve a desired outcome. Option B, it says a mathematical equation. While a mathematical equation can be used within an algorithm, they did not encompass the broader concept step-by-step instructions because this is wrong. The option C, random instructions. Algorithms are designed to be logical and have a clear logic flows. Randomness goes against the core principles of algorithm. Algorithms are step-by-step instruction or procedures. Then it's wrong. D, a programming language. Programming languages are tools used to implement an algorithm. They provide the syntax, the structure for writing the codes, and that represents algorithms steps. And then it's wrong. It's not programming language. Question number 2. What is the primary purpose of analyzing an algorithm? A, to make them more complicated. B, to improve their efficiency. C, to confuse programmers. D, to increase their legacy. Question number 2. What is the primary purpose of analyzing an algorithm? A, to make them more complicated. B, to improve their efficiency. C, to confuse programmers. D, to increase their legacy. The correct answer is B, to improve their efficiency. Analyzing algorithm is essential in order to understand their performance and efficiency. By analyzing algorithm, programmer can determine how well a particular program or algorithms will perform in a different scenario and make necessary improvements to optimize its efficiency. The other incorrect options, for example, option A, to make more complicated. This is not the primary purpose of analyzing algorithms. The goal of analyzing algorithm is to simplify and improve algorithms, not making them more complicated. The other option C, to confuse programmers. Analyzing algorithm is meant to provide clarity and understanding, not a confusion. And this is not the correct answer. Option D, to increase their length. The length of an algorithm is not necessarily an indicator of its efficiency. The primary focus should not increase the length. It focuses on improving efficiency. Question number 3. Which of the following is not a common method for analyzing an algorithm? A. Empirical analysis. B. Asymptotic analysis. C. Syntax analysis. D. Complexity analysis. The correct answer is C. Syntax analysis. Syntax analysis is a technique used in a compiler design to check the code for the syntax error. It's not the common method for analyzing algorithm because it focuses on the code structure rather than its performance. What about other options? Option A, empirical analysis. This involves running an algorithm on various inputs and measure its execution time and resource usages. This provides practical insights into algorithm performance for real-world scenarios. Option B, asymptotic analysis. This method focuses on how an algorithm performance scales with very large input size. By analyzing the dominant terms in algorithm, times and space complexity, we can predict its behavior for a large data set or large inputs. D, complexity analysis. These refer the process of estimating the time and space complexity of an algorithm. The time complexity refers the amount of time it takes to run an algorithm, while space complexity refers to the amount of memory the algorithm uses. Understanding this complexity helps us to compare different algorithms and choose the most efficient one for your specific tasks. Question number 4. Which notation is commonly used to represent the worst case time complexity of an algorithm? A. Big O notations. B. Theta notations. D. C. Omega notations. D. None of the above. The correct answer is A. Big O notations. Big O notation is commonly used to represent the upper bound or the worst case time complexity of an algorithm. It describes the upper bound of the growth rates of a function, providing an estimate of the longest amount of time an algorithm can take to complete the worst case scenario. Option B, theta notation. This notation represents an average case time complexity of an algorithm, not especially the worst case scenario. C, omega notations. This notation also represents the best case time complexity of an algorithm, not especially the worst case scenario. D, none of the above. Question number 5. What is the time complexity of an algorithm if it is big of n square? A, quadratic, B, linear, C, exponential, D, algorithmic. The correct answer is A, is quadratic. The time complexity of an algorithm being big of n square indicates a quadratic time complexity. This means that the running time of algorithm grows quadratically with the input size. But the other options, B, it says linear. This is not a linear, it's a quadratic. It's not a linear time complexity, it is a quadratic. Option C, exponential. Yes, it is not option. Exponential, it is quadratic. Logarithmic, then it's not logarithmic. This is incorrect as logarithmic complexity. Maybe this is a logarithmic big of log n, maybe for exponential big of to the power of n or similar, or linear maybe n. Question number 6. Which of the following is not a factor in algorithm analysis? A, time complexity, B, space complexity, C, color complexity, D, input size. The correct answer is C, color complexity. This color complexity is not a standard factor in algorithm analysis. But the other options, for example, A, time complexity, this is a fundamental factor in algorithm analysis, as it helps us in understanding how the running time of an algorithm grows with the input sizes. B, space complexity. This space complexity is another essential factor in analyzing algorithms, as it determines the amount of memory space required by algorithms to solve a problem based on their input sizes. The other option D, the input size. The input size is the key factor in analyzing an algorithm, as it directly impacts how algorithm performs with different input sizes. Understanding how an algorithm scales with input size is crucial for assessing its efficiency and performances. Question number 7. If an algorithm has a time complexity of big of n, what can be said about its performance? A, it has linear time complexity. B, it has algorithmic time complexity. The correct answer is A, it has linear time complexity. Linear time complexity denoted by big O of n, that means an algorithm running time grows linearly with an input set. This implies that As an input size increases, the time taken by an algorithm also increases proportionally. But B, it has logarithmic time complexity. Logarithmic time complexity is denoted by big O of log n, and it describes an algorithm where the time taken grow logarithmically with an input size. Option C, it has constant time complexity. This constant time complexity denoted by big O of 1. That means an algorithm running time remain constant regardless of the input size. Option D, it has quadratic time complexity. This quadratic time complexity denoted by big O of n, big O of n squared. It signifies that an algorithm running time grows quadratically with an input size. Question number 8. If an algorithm has a time complexity of big O of 1, what can be said about its performance? A, it has a constant time complexity. B, it has linear time complexity. C, it has logarithmic time complexity. D, it has exponential time complexity. The correct answer is A, it has a constant time complexity. An algorithm with a time complexity of big O of 1, it signifies that regardless of an input size, the time taken for an algorithm run remain constant. It cannot be changed when the input size increases. This is considered highly efficient as the execution time does not increase, the input size grows. The other options, option B, it has a linear time complexity. This is incorrect as the linear time complexity means the time taken by an algorithm increases linearly with input size increases. When the input increases, the algorithm running time also increases. This is incorrect. Option C, it has logarithmic time complexity. This is also incorrect as logarithmic time complexity would mean the time taken by an algorithm increases logarithmically when the input's size. Option D, it has exponential time complexity. This is also incorrect as exponential time complexity would mean the time taken by an algorithm grows exponentially with the input size. Question number 9. Explain the significance of big O notation in algorithm analysis. A, it represents the upper bound of the time complexity of an algorithm. B, it provides the exact running time of an algorithm. C, it signifies the best case scenario of an algorithm. D, it is used to analyze the space complexity of an algorithm. The correct answer is A. It represents the upper bound on the time complexity of an algorithm. The big O notation is a crucial concept in algorithm analysis as it represents the upper bound on the time complexity of an algorithm. This notation helps us in understanding how the current runtime of an algorithm grows as an input size increases. The option B, it provides exact running time of an algorithm. It is incorrect because big O notation does not provide the exact running time, but rather an estimation of how an algorithm performance scales with input size. Option C, it signifies the best case scenario of an algorithm. Then it is incorrect because big O notation typically focuses on the worst case scenario rather than the best case scenario. Option D, it is used to analyze the space complexity of an algorithm. Yes, it is incorrect as a big O notation primarily deals with the time complexity analysis, not space complexity. Question number 10. Compare and contrast the big O notation and theta notations in terms of their significance in algorithm analysis. A, big O notation represents the upper bound, while omega notation represents the lower bound. B, big O notations is used for average complexity, while omega notations is used for the worst case complexity. C, big O notation provides a tight bound, while omega notation provides a loose bound. D, big O notation is used for space complexity analysis, while omega notation is used for time complexity analysis. The correct answer is A. Big O notation represents the upper bound, while omega notation represents the lower bound. Because when you say the significance of big O notation and omega notation in algorithm analysis, these both are essential tools in analyzing algorithm analysis for evaluating the time complexity of an algorithm. They provide valuable insight into how algorithms running times grows as an input size increases. This big O notation represents the upper bound of an algorithm time complexity. It specifies the worst case scenario in terms of runtime. It helps us in understanding scalability of an algorithm by indicating the maximum time of an algorithm it takes to execute. Then also it allows to developer to make informed decision about an algorithm selection based on their performance requirements. When you move to this omega notation, then also it represents the lower bound of algorithm time complexity. It indicates the best case scenario in terms of its running time. Then it offers insights into the minimum time of an algorithm required to compute under ideal conditions. Enable developers to understand the lower limits of an algorithm performance and make comparison between different algorithms. Based on this, both big O notations and omega notation plays crucial roles in analyzing algorithms and also are utilized to assess and compare efficiency of different algorithms. The other options, big O notation is used average case complexity. No, this is wrong. While omega notation represents the worst case. No, it's wrong. C, big O notation provides tight. No, this is theta. omega notation provides loose bound. No. Big O notation used space complexity analysis, while omega notation used time complexity. No. These two of them used for time and space complexity. The correct answer is C. Time complexity analysis helps in preventing the algorithm's performance on different input sizes. The time complexity analysis is the crucial aspect of an algorithm design. It allows you to understand how the execution time of an algorithm grows as the size of input increases. This is essential for several reasons. One, efficiency comparison. Two, scalability prediction. Three, resource optimization. For example, when you go to efficiency comparison, you can compare different algorithms for the same problem and chooses the one which the better time complexity. For example, the linear time big O of n algorithm will generally outperform a quadratic times big O of squares, n squares, an algorithm for a large inputs. The second one, scalability prediction. The time complexity helps predicting how well an algorithm will handle large data sets. An algorithm with a slow time complexity might be suitable for small inputs, but become unmanageable for large inputs. The third one, resource optimization. Knowing the time complexity helps you to estimate the computational resources needed to run an algorithm. This is critical for application which is limited processing power or battery life. The other options, option A, time complexity analysis is irrelevant in determining efficiency of an algorithm. This is entirely wrong. Time complexity is the fundamental metrics for gauging an algorithm efficiency. B, time complexity analysis is only applicable for recursive algorithms. While recursives can affect time complexity, it is not limited to recursive algorithms. Iterative algorithms also have time complexity based on times the loop through the data. D, time complexity analysis focuses on the space requirement of an algorithm. This time complexity deals with execution time, not the space usage. Space complexity analysis is a separate but equally important concept for understanding algorithms' memory requirements. By understanding the time complexity, you can design and choose an algorithm that are efficient, scalable, and suitable for specific problems and data, the size you are working with. Question number 12. explain the concept of space complexity and its importance in algorithm analysis. A. Space complexity refers to the amount of memory required by an algorithm to run. B. It is irrelevant in determining the efficiency of an algorithm. C. Space complexity is always direct proportional to time complexity. D. Space complexity is represented by theta notation. The correct answer is A. Space complexity refers to the amount of memory required by an algorithm to run. Space complexity analysis how much memory an algorithm consumes as an input size grows or increases. It is crucial for efficiency as memory limited can slow down or crash the programs. That makes the program slow. Option B, it is irrelevant in determining the efficiency of an algorithm. That is incorrect. Space complexity is very relevant to efficiency. If an algorithm requires too much memory, it might not run all programs or systems, or it may become sluggish. Option C, space complexity is always direct proportional to time complexity. Is also incorrect. Space and time complexities are often related, but not always proportional. Sometimes, maybe high time complexity, or maybe low, but space complexity always constant. It's not always proportional. An algorithm might use constant memory, independent of input size, while having a complex runtime. Option D, space complexity is represented by theta notations. Incorrect. Space complexity is typically expressed using big O notations, not the theta notation. Big O notation represents or describes the upper bound of resource usages. Question number 13. Discuss the role of asymptotic notation in simplifying the analysis of algorithms complexity. A. Asymptotic notations provides a concise way to describe the algorithm growth rate of algorithms running time. B. Asymptotic notations are only applicable to small-scale algorithms. C. Asymptotic notation focus on precise calculation of algorithms running time. D. Asymptotic notations are always used to analyze the space complexity of an algorithm. The correct answer is A. Asymptotic notation provides a concise way to describe the algorithm, the growth rate of algorithms running times. These asymptotic notations, that means big O or big theta or big omega, it's a mathematical tool specially designed to analyze the growth rate of algorithm complexity as an input size approaches infinity. These asymptotic notations are a powerful tool for simplifying the analysis of algorithm complexity by providing the concise and high level of understanding of how algorithms execute timescales with the input size. The other options, B, asymptotic notations are only applicable to small-scale algorithms. This is incorrect. Asymptotic notations are the most useful for understanding large-scale algorithms. where the growth rate become more significant. Option C, asymptotic notation focus on precise calculation of algorithms running times. This is not entirely true. They focus on the broader aspects rather than the precise calculations that would be dependent on specific hardware and implementation details. Option D, asymptotic notations are used in analyzing space complexity of algorithms. While asymptotic notation can also be used for space complexity analysis, their primary application is analyzing running times, or the time complexity of an algorithm.